chapter for simultaneous equation.
Are we supposed to write that down?
Yes, please. So that you have good organization.
Right where?
In your book out.
Of course I know in the book, right? On your head. Or in the light.
In the middle of the book. You write from the bottom. Right here, right bottom. Then you write outwards. Okay? Can you please use your brain to think? Alright? Okay, so what is this simultaneous equations thing? Okay, so previously we have already covered, okay, how to solve simple linear, okay, so in the past, okay, previously. Right? We have learned how to solve x plus 3 equals to 5 or 2x plus 9 equals to 16. Okay, so we know how to solve this kind of questions already, right? Okay, so very quickly, can someone tell me x plus 3 equals to 5, what is x going to be? 5 minus 3, that's 2, right? Okay, then 2x plus 9 equals to 16, what do we get? 2x equals to 16 minus 9, so that's 7. And we see that x equals to 3.5. Okay? So when it comes to solving things like that, right, when given an equation, we find that there is only one solution. It's for your benefit, right? Yes. Whatever I write on the whiteboard is going to be important. Okay, we need to gradually increase the speed of writing. But must write. Okay, so now that we have already learned how to solve all this, right? Okay, how about if I want to solve things like x plus y equals to 5? Okay, whereby we have two unknowns over here, x and y. There are going to be many possibilities whereby two numbers add together become 5. I can have 1 and 4 equals to 5, 2 and 3 equals to 5. 1 and a half and 3 and a half equals to 5 as well. 1.2 and also 3.8 will give you 5 as well. Okay, so in fact there are many possibilities. Okay, so in this case, for simultaneous equations, we are not looking at many possibilities. Okay, what we are going to do is to solve two equations, right, together. So for instance, right, if I have two equations, okay, our concern now is that going to be our main concern for this entire chapter. Okay, what is the common x and y value that satisfy both equations? Okay, so as I mentioned just now, x plus y equals to 5. I can have 1 and 4 equals to 5. I can have 2 and 3 equals to 5. There are going to be many possibilities. Okay, but I want a solution such that it not only is going to fulfill this equation, it is also going to fulfill this second equation over here. So there's only going to be one solution, okay, for both of this to happen. Alright? So that is the skill that we are going to acquire in this chapter. Okay? So there are three main skills. That we are going to cover. We are going to look at elimination, substitution, followed by graph. Going to be a lot of copying. You may have to consider buying a smoother pen so that you can write faster. Is going to be recorded. If you miss out anything, you can go back and check the video. Okay. Right. Let's start. Okay. So stop writing. Listen first. Okay. We're going to start with elimination method. Okay. I think in primary school we have done questions like this before, whereby I tell you 3 pencils and 5 erasers cost $12. 2 pencils and 5 erasers cost $10. Okay? We want to find the cost of each item. How do you do it in primary school?
One pencil. That's very expensive.
Okay, what do you do in primary school? Yes, Declan.
Take $12 minus $10, find how much more than $10.
Okay, so Declan suggests that to find out cost of 1 pencil, we will just take $12 minus $10 and you will find that the pencil costs $2. Okay, so why is it that such a method actually works? Why do you suggest such a method, Declan?
Because the difference is $1.
Okay, so we're looking at the difference over here. Okay, when we're doing this method, we're looking at the difference. So when in order for us to do this difference, right? Okay, what must happen in the situation such that I can do this? Will it work if instead of 5 erasers, I have 3 erasers over here. Will this method work then? No. So what is the most important thing that allows this method to work?
Everything on the other side is the same.
The other side is the same. Very good. Okay, so we find that because there are 5 erasers for both of the situations, okay, I will be able to find the cost of 1 pencil. So even if, okay, down here maybe I say 1 pencil instead, okay, it will allow us to focus on the pencil only. Okay, so this method over here, okay, let me go back, right? So this method, okay, I just try to reduce the handwriting. This symbol here represents the cost. Okay, but of course in exam don't write such symbols. It is the opposite, 3 dots like that. This means because. Okay. 3 dots. The other like that is therefore.
Whoever invented was a person.
Okay, it's a shorthand writing. Okay, so you may need to write in shorthand. Doesn't mean that you grow your hand shorter. Okay, so this method works because there is something in common. And that is the 5 erasers for this question. Okay? Then upon being able to find the cost of 1 pencil already, okay, we can find the cost of the eraser. How do I go about finding the cost of 1 eraser? Yes, Ryan.
You add up the pencil cost, then you use the total amount minus the eraser.
Okay, so we can find the cost of maybe either you can find 3 pencils or 2 pencils. So up to you. So in this case, if I want to find the cost of 3 pencils, I will find that it is $6. So the cost of 5 erasers will be 12 minus $6. And we find that the cost of 1 eraser is now $1.20. Okay, I know it sounds very expensive for eraser, but looking at the fact that Declan today has a mechanical eraser, okay, you can afford one, automatic one. I think this isn't going to be expensive anymore.
Pencil is more expensive than eraser.
Declan, how much is the eraser?
Yeah, of course, isn't a pencil more expensive than eraser?
Huh?
A mechanical pencil surely more expensive than eraser.
What is the normal pencil?
Chips, yeah.
Who say normal pencil? I never say anything.
All these pens
Oh yes, right. Yes, this is all under the primary school method, right? Okay, primary school we do such calculations. Okay, so now how do we actually put this into a secondary school context? Okay, of course in secondary school we're not going to be focusing on pencils and erasers only. Okay, we're going to look at more algebra, okay, more abstract ideas. Okay. I want you to listen up first, okay, before I start talking. I'll give you the time to copy later on. Okay, so in secondary school, okay, how we're going to rephrase this context is that, okay, we will let cost of pencil px, cost of 1 pencil, sorry, and 1 eraser y. Okay, so usually in the exam itself, they will tell you what is x and y. You don't really have to do this. So we will define that. Then from these 2 statements, how do I write an equation out of this? Okay, since you're looking at 3 pencils and 5 erasers, that means that 3x plus 5y equals to 12. Okay, then in the second statement here, 2 pencils and 5 erasers, that will be 2x plus 5y equals to 10. Okay? I want you to really stop writing, listen to what I have to say first. Okay, because this is going to be crucial for whatever we're doing next. Okay, so what we do is that after we get these 2 equations, we will label them 1 and 2 I label it in such a manner with a circle. Okay, because if you don't put in the circle, it's going to look like -1, -2. It's going to be confusing. So I want you to draw a circle around it. So that's the way of naming this particular equation. Okay, so earlier on, we find the cost of pencil by taking the first one minus the second one, $12 minus 10. So what we'll do is, I will take the first equation minus the second equation. So that is the instruction, okay, over what we're going to do. Alright? In the exam, you need to present your answers out like that clearly. Okay? And in doing this, okay, I'm taking first equation minus second equation. So actually, first one has 3x plus 5y. Minus away 2x plus 5y. That is on the left hand side of the equal sign. Then equals to, on the right hand side of the equal sign, we have 12 minus 10. Okay? So of course we can see things fast enough because we have this context over here. We see that eventually I'm trying to find the cost of one pencil. So the whole idea is that when we open up the brackets, I'm going to have it like that. This one changes to a minus. So that's why 5y minus 5y becomes 0. And we have 3x minus 2x that becomes x. So that's why we see that x is equals to 2. Okay, are we comfortable with this so far? Okay, we understand this, huh? Right? Maybe you're not comfortable, but we understand what's going on, right? Okay, so we see that x is equals to 2. Okay, then after that, now that we have x equals to 2 already, we need to find out what is y because we need to know what is the cost of one eraser. Okay, so we will let x equals to 2 into any one of this, just like in this process over here, where I go and find the cost of 3 pencils. So in doing that, okay, 3x plus 5y is equals to 12, I use the first equation. Technically, I can do first equation or second equation because over here, I can go and find 3 pencils or 2 pencils. It depends, right? If I use 3 pencils, then this is the working. If I do 2 pencils, then I will take $10 minus away cost of 2 pencils. Okay, so let x equals to 2 in the first equation. That will mean that I will have 3 bracket 2 because I replace the x with the value of 2. Okay, plus 5y equals to 12. And then we are familiar with how to solve this kind of equation, right? So we get 6 plus 5y equals to 12. 5y equals to 12 minus 6 equals to 6. Okay, let me bring it up. So y is equals to 6 divided by 5. And we find that y is equals to 1.2. Okay, so this will be how an algebra approach will be like, alright, whenever you do elimination. Any questions? Yes.
What do you mean by that?
Okay, let x equals to 2 in y. It's just like over here, I go and find 3 pencils. So I take 3 times 2. So when I take x equals to 2, I put it into this equation here. Okay, so I replace the x with 2. So that's the meaning of let x equals to 2 in 1. 1 is this equation here. Okay, any other questions? Alright, I'll give you, yes, Spencer, sorry. No, it is not the substitution method. We are sticking with elimination method over here. I don't want you to go and look at substitution method yet. Okay? Essentially, yes, you're substituting a number, but let's drop that word first. Okay? Let's look at this is an elimination method because we are eliminating, okay, the y over here. Alright? I'll give you 1 minute to copy. Jaden, do you want to shift in front? Cost of pencil is $2. Cost of eraser is $1. Okay, done. Alright, so I want to address, okay, over here, why is it that this is called the elimination method? Okay, this is the elimination method because what exactly are we eliminating? Okay, eliminating means that we are removing. That's the meaning of elimination. Alright, removing. So over here, when we did a primary school method, I cancelled out the 5 erasers. Okay, so because there's something in common, I cancelled that out. So that is the process of elimination. Okay, now over here, okay, we are also cancelling out the 5y because this is positive 5y, this is negative 5y. So it gets cancelled out. Okay, so that's why we have the idea of elimination over here. Okay, now let's go to an example. Let's look at the worksheet. There's example 1. You don't have to copy down the question. Questions I always write it in black. Working, I write it in blue or other colors. Okay, so you write down the working only. So to ensure that you have things neatly, okay, you can write example 1. Okay, you may want to write it in the small column on the left, up to you. Okay, it's just your preference. Alright, or you want to write it as a header also fine. Okay. So example 1 itself, okay, we want to use elimination method to solve x plus 10y equals to 27 and x plus 5y equals to 12. Okay, this question is already found in your worksheet. So no need to copy the question, yeah? Okay, but you may need to copy down these 2 equations. So equation 1, equation 2. Okay, these 2, but because they are going to be part of your working. Okay. Okay, so we understand that for elimination method to work, we must have things that are in common. So can you tell me what is in common between these 2 equations? And see that x is in common, right? So we can eliminate and cancel away the x, okay, by doing equation 1 minus equation 2. Okay, at this point you may be wondering, can I take equation 2 minus equation 1? How many of you think can? Okay, who thinks no? Must be equation 1 minus 2. Wait, who says that taking equation 2 minus 1 also can? Okay, yes. Right? So it is not compulsory that we will take equation 1 minus 2. You can also take equation 2 minus 1. Right? Answer will still remain the same. Okay? Because the whole essence over here is that we see that x is the one in common. Okay? So when I do 1 minus away 2, like I said earlier, we look at the left hand side of the equal sign and the right hand side of the equal sign. Left hand side we have x plus 10y from the first equation, so equation 1, minus away the left hand side of the second equation. Then I will take equals to 27 minus 12. Okay? But of course, if you can see things fast enough, because it is the elimination, you know that eventually you're supposed to get 10y minus 5y. Do we agree with that? Okay, because we're eliminating this, right? We know that very clearly it's 10y minus 5y. Okay, so technically, when I open up these brackets, I should eventually be getting 10y minus 5y. And that's true because x minus x, that's 0. So 10y minus 5y. Then on the right hand side, I will go and compute it. I see that it is 15 on the right side. So 5y equals to 15. And y will be equals to 3. Okay, any questions so far? Do we just stop here? Y equals to 3. Who thinks that that's all? That's all that I have to do. 5y equals to 3, that's all. We need to find x also. So always remember, there are two things, x and y, that we need to go find. So don't just stop here. Okay, so you may want to write down a reminder, don't just stop here. Okay, remember must find both x and y. Okay, so in order to find x, now that we have y already, okay, I can put back into the original equations. So equation 1 or equation 2. I'll let you decide what you want me to put it into.
The small one.
Let y equals to 3 into equation 1 or equation 2. Okay, I'll go with 2. So if I let y equals to 3 in 2, what I will be having is that x plus 5 bracket 3 equals to 4. So I replace the y with the value 5. With the value 3, which is what the value of y is. Okay? So now we have x equals to negative 3. In case you don't believe me that putting into any of the equation is the same, so let me just show you. Even if I put back into the first one, I will still see that x is negative 3. Okay, so surely the value will be the same. Alright? Nicole, are you copying anything? Can you also print out the page? Any questions over here? Can accept this? Okay, okay. So let's look at example 2. Yes.
First one and like the circle line right hand side.
You can what?
Right hand side.
Yeah. This one, this thing is the circle thing. You're supposed to write it. You must label the equations. Okay? Usually the first one I see I label as 1. This one label as 2. Okay? You don't go and label this one second one, this one 1. Then the other one what? Label as 0, man. Okay, no. Right? Okay, so we label 1 and 2. Okay, no other namings. Please don't give it a name, Mary and Tom. Okay, no. Doesn't make sense. Then you take Tom minus Mary. No. Okay?
Tom plus Mary.
Equals to.
Okay, next we look at example 2. We have these two equations over here. Same thing, I label 1 and 2. Okay, we notice that this is slightly different. Okay, in example 1, we have x to both be positive x. Okay, and then we minus them out. Over here, we have negative y and negative y. Okay, can we still do this elimination like that? Where I take 1 and 1 minus away 2. How many of you think that I can still do equation 1 minus equation 2? Who thinks cannot take equation 1 minus equation 2? Lesson end already? Okay. Equation 1 minus equation 2, who says cannot? Cannot? Okay. Then the rest of you don't know. Not sure. Okay? Yes, I know, yes. But the rest, nobody raise hand. Alright? So in this case, we still go back to the same idea. In the elimination method, both things must be common, must be the same. So over here, both are positive x. Down here, both are negative y or minus y. Okay, so it still remains the same. So I can still do equation 1 minus equation 2. Okay, let me show it to you. Left hand side minus, then equals to right hand side minus both of them. Okay, open up the brackets. I will get this. So what do I see over here about the y's? I have this to be minus y, this to be plus y. Do they cancel each other out?
No.
Yes or no? What is minus y plus y? Is it 0 or is it minus 2y? My question is it 0 or minus 2y?
0.
It's 0, okay? Just like negative 1 and plus 1 becomes 0. So negative y and plus y becomes 0 also. So it cancels out, it gets eliminated. So we have 5x minus 3x equals to 6. Okay, then 2x equals to 6. X is equals to 3. Any questions? Jerry, you understand? David, you understand? Oh. You still processing? Never mind. Okay, so now we finish up the question. We let x equals to 3 into first equation. I erase this part, yeah? So I let it into equation 1. Replace the x value as 3. I will have 15 minus y equals to 11. This is a positive 15. So I bring over become minus 15. I'm left with negative y. I will have negative y equals to negative 4. Do I leave the answer like that?
No.
Because the question wants to find y, positive y. So y is equals to 4. Okay, so that will be the two answers, x and y. Okay, please go back home and digest this idea. Alright, next lesson, please make sure you have your chapter 4 workbook with you. Okay, so please head out before the lesson itself. We will continue with this next time round.